Hello, welcome to a new virtual tour of the European Southern Observatory, or simply ESO, its acronym. My name is Farid Char, and with the producer Hector Salas, we are going to be your guides during this trip to the ESO Paranal Observatory. Just a little bit about me. I have more than 15 years of experience in astronomy outreach and education. I am one of the guides of the observatory since 2010, and I have worked for an astronomy center in the University of Antofagasta. And regarding my personal hobbies, well, I am interested in the astrophotography. Well, today I am not alone. I am with producer Hector. How are you, Hector?
Hi Farid, I'm happy to be here once again. So to introduce myself, my name is Hector Salas. I'm a PhD student at the Leibniz Institute for Astrophysics in Potsdam, Germany. My research is focused mostly on topics related to the circumgalactic medium, that is the environment that surrounds galaxies. I've been a part of the team of guys from Paranal Observatory since 2019. I started while I was doing my master's at the University of Antofagasta. And today I will be the producer, and that means that I will be changing the pictures, the videos, but I will also be reading all your comments and questions. So please, if you have any doubt, send us a comment either on Facebook or on YouTube, and Farid will have some pauses during the tour to answer them as best as we can.
Okay, thank you very much, Hector. Well, yeah, ESO wants to be with you during these virtual visits and bring astronomy directly to your home or wherever you are. So we can allocate some time later to answer some questions. Okay. Okay, so we are going to start immediately, and we are going to start explaining a little bit about the organization. So we will begin with some information about the European Southern Observatory, or ESO. So ESO is composed of 16 member states. The headquarters of ESO are located in Germany. Also, Australia has joined ESO as a strategic partner, and Chile is the host state and home of all ESO observatories. So from the 60s, and with those objectives in mind, ESO has chosen one of the best places on the planet for astronomical observations, the Atacama Desert in Chile. During this period, Chile started several site explorations in order to attract international observatories such as ESO to our country. As a result, Chile offered its territory and ESO did choose the more suitable areas. So the mission of ESO is to design, build, and operate astronomical observatories. And why? To enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy field. So in a few moments, we will see a picture with the 3 observation sites of ESO in Chile. So here we have the Chajnantor Plateau. This is the site of the ALMA radio telescope. ESO is part of this big radio astronomy observatory alongside other international partners. Additionally, south of Atacama Desert at 2,400 meters above sea level, we have La Silla Observatory in the Coquimbo region in Chile. So this ESO observatory is the home of several telescopes such as the NTT or the 3.6 meter ESO telescope. And this one is using the HARPS instrument, and this is an exoplanet hunter. And finally, we have the place of our visit, Paranal Observatory. So this ESO observatory is the home of the Very Large Telescope, or VLT, the most advanced visible light telescope on Earth. In the next few years, we will also have the Extremely Large Telescope, or ELT. This will be the biggest visible light telescope on Earth. Also, the CTA will be an array of telescopes focused on capturing gamma rays. Okay, so now we have a better picture. So now let's travel to the Paranal Observatory. So now virtually you are flying over the Atacama Desert in the north of Chile. about 1,600 kilometers north of the capital Santiago, specifically about 130 kilometers south of Antofagasta, the regional capital, and about 90 kilometers north of Taltal, the closest city. So now we are going toward the mountain top of Cerro Paranal, located at 2,600 meters above sea level. This mountain belongs to the coastal range, and despite its altitude, it is located at just 12 kilometers from the coast. And where is the ocean? Well, the Pacific Ocean is located below this cloud cover. And why those clouds, if right here the sky is so clear, dry, and lonely? Well, this is because of the influence of the Humboldt Current. This is a cold current near the coast of Chile and Peru, cooling the atmosphere and causing a phenomenon called thermal inversion at about 1,000 meters above sea level, keeping below the cold, humid, and basically bad air for astronomy. Now, about the layer, instead, we have the hot, dry, and less dense air. So this is the good air for astronomy. The clouds are blocked by the coastal range, and near Paranal, the mountains are high enough, surpassing 2,000 meters above sea level. Now, we have other natural barriers around this area. About 200 kilometers to the east, we have the Andes Mountains, with very high mountains, more than 6,000 meters above sea level. So this is another natural barrier blocking the clouds from Argentina and Bolivia. So the main result is this landscape, a place with an average of more than 300 clear nights per year, with a very clear and transparent atmosphere, making it ideal for observing the night sky. Also, here we are far away from artificial light sources because of human activity. I mean the light pollution. So this is one of the best places on Earth for astronomical observations. Okay, so right now we will change the view to have an even closer look to Paranal. So as you can see, this is not an ordinary mountain. And now we can see the different telescopes and structures in the mountain. We are at the summit of Cerro Paranal. So do you know what Paranal means? Well, in the Quechua language, Paranal means whirlwind, possibly because of some whirlwinds forming in the desert. However, as I told you already, the atmosphere here is extremely quiet. So this observatory is a true oasis. You will see how in one of the driest deserts we have a lot of life and a lot of science. So right now we will visit the summit of Paranal. Okay, so in front of us we have the Very Large Telescope, or the VLT, its acronym. So if you see the amount of buildings here, I mean 4 giant domes and other 4 small and rounded ones, I mean like this one, it's clear that the Very Large Telescope in fact is not only one, but a very special array of telescopes. So all this facility is the most advanced optical observatory on Earth. So let's take a closer look. So in first place, here you can find the 4 unit telescopes, or UTs, each one with a primary mirror of 8.2 meters of diameter. Okay, so the giant ones in your screens. And the other small ones are the auxiliary telescopes, or ATs, each one with a primary mirror of 1.8 meters of diameter. So we have one here, we have another one here, we have this one here, and we have the last one right here. Okay, so each UT, I mean the big ones, they have a name in Mapudungun. This is the language of the Mapuche people, natives from central and south of Chile. So here we have Antu. Antu means sun. This one is Cuyen, which means moon. This one is Melipal, which means 4 stars, but this is related to the Southern Cross constellation. And this one is Jepun, and this word is related to the planet Venus. Okay, and as I told you already, we have other telescopes near here. We have the auxiliary telescopes. Okay, now the important thing about the auxiliary telescopes is that they are mobile, so we can move the small ones using a rail system right here, and you can see that we have some stations here. Okay, so actually we have 30 different stations or positions. Okay, so they were specifically designed to work all together as a single big telescope with a variable diameter, able to reach up to 200 meters, as you will see in a few moments in a short video. So the technique to combine light from several telescopes is called interferometry. So we are able to observe much more specific details if you compare this with the individual telescopes. So thanks to interferometry, we can simulate a giant mirror to distinguish details up to 16 times fainter than a single telescope. So why don't we make small telescopes and combine them to create a huge telescope? Well, interferometry also has limits, and some information is lost during its travel. However, it is still an excellent solution to observe objects too difficult to observe with our current technology. Okay, so right now we will come back to the tour screen because now you will have the opportunity to visit one of the telescopes. We are going to access UT3 Melipal. We can't enter all the telescopes, but this is not an issue because the 4 ones are identical in size and shape. So the only difference are the instruments inside. You can know more about the instruments if you visit the ESO website. Okay, so now we are going to access the UT3. And here we are. Okay, now we are on the UT3 or Melipal. And what can you see? Well, this is a giant telescope. Okay, so we are on the last floor of the telescope at the same height of the main mirror in front of us. I will do a close-up here so you can take a closer look. So this mirror has 22 tons with 8.2 meters of diameter and only 17 centimeters thick, created from a ceramic and flexible material. And the name of this material is Cerutur. And the material of the surface is a very thin layer of aluminium. Okay, so this is the reflective material. Now you need to understand that every night this telescope has to move to different positions in the sky. So at some point, and because the mirror is so heavy, we need to be very careful to prevent that the mirror. I mean, we don't want the mirror to break. So we need to understand a little bit what happens with the mirror because we have a very interesting technology acting on the mirror. I will show you the telescope from this surface, from this floor, to explain a little bit more about the mirror. Okay, so from this point, we can see the mirror. I mean, we can see the cell underneath. Okay, this cell is supporting the mirror. And this is important to mention because we need to understand how can we point this telescope to the sky, to different positions in the sky, without breaking it. So the mirror is mounted over this white structure. And this is a cell supporting all systems assisting the mirror, including something called active optics. So I have to do a close-up here because I have to show you this. Okay. Here you can see some little gray boxes. They are called actuators. They are a kind of piston, and we have 150 in total. controlled by a computer. So they are acting on the mirror during the observations in order to keep the optimal shape of the concave mirror, because this mirror is concave. It's like a spoon. So otherwise, it could suffer deformations just because of gravity or physics. And those deformations, imperceptible in a first view, could be critical in the result of the observations. So how is this working together? We will come back to explain that. So we are going to return to the previous screen. And from this position, I want to explain a little bit how the telescope is receiving light. So to do that, we will show you a short animation. And in this animation, you can see that the first step, well, we need to open the dome. Of course, this is exaggerated in this animation. We have the light coming inside, and the primary mirror will receive the light. The light will be concentrated and reflected to the secondary mirror in the top. The light will be reflected again to a tertiary mirror in the middle, and from this point, the light will be reflected to one of the instruments. We have one instrument at each side and one in the bottom. Is this kind of blue, red, and green devices there. So the instruments will be in charge of converting the physical light into a digital signal. Okay, so all this animation, in order to understand, well, the primary mirror is here, the secondary mirror is here, and the tertiary mirror is here, but you cannot see it because it's well, it's blocked by this structure, and the instruments are located in this side, in the other side, and in the bottom. So here you can see, for example, one of the instruments, and you can see some engineers there here, because we have engineers working every day, doing maintenance, fixing problems, doing calibrations. So they are basically preparing the telescope for the next observation night. So let's say that the daytime work in Paranal, and actually in any modern observatory, is for engineers, and the nighttime work in Paranal is for astronomers. So that's why we have engineers here. But during the night, all this place is completely in darkness. Okay, so the telescope will be controlled from a control room. We can do a remote control of the telescope, so we don't need the astronomers to be here physically. So our next stop will be the control room, actually. So in order to explain the workplace of the astronomers, we need to go out, because, well, this is the end of the explanation here in the telescope. So now I will come back to the platform, and the next stop will be the workplace of the astronomers. So I have to move to this location, and you can see this building here. This building is the control building. You can take a quick look from the opposite side. So this place is the workplace for the astronomers, and we are going to explore this place in a few moments. But before doing that, I don't know, Hector, if we have some questions from the virtual visitors.
We have a couple of greetings. We have uh, at Valenciana Bolicor saying hi. We have Guardian giving us a thumbs up. Uh, Irangel was asking about subtitles and translations, so maybe we can take the opportunity to clarify that we do these tours in English, but also in Spanish, and we're alternating between the two languages. So next week should be the same tour in Paranal Observatory, but in Spanish, in case he speaks Spanish. And we also have some greetings from Peru, and Mike also gives greetings, but we don't have any question yet from our viewers. So let me ask you one. What kind of maintenance does the observatory needs for the telescopes?
Well, yeah, the more we have a lot of maintenance, but of course the most important maintenance is about the mirror. So I want to access the mirror again to explain that. So you have the primary mirror of 8.2 meters, and we need to do an important maintenance on the mirror to keep the mirror in perfect conditions. So we have two ways to clean the mirror. One way is like an easy way, and in order to do that, we need to rotate the mirror a little bit, and a couple of engineers will use some special device to spread a carbon dioxide snow on the mirror. So this is something like a foam. So this element will remove dust from the mirror because, well, we are in the desert, we have dust. But this is something like an easy maintenance because we need to keep the mirror in optimal conditions, and we need to do that about once a month. But we have another maintenance, and this is more complex. And this maintenance requires to remove all the mirror from this building. So in this case, we need to extract the mirror here and the white cell. Okay. So in order to do that, we need to use some special cranes. And this dome, there is some specific door, okay, to remove the mirror. So, for example, from the VLT platform, we can see in this picture a yellow structure here, okay? So you need to put the mirror here. And at the ground level, we have a special vehicle waiting for the mirror. So we need to, let's say, drop the mirror very gently, of course, from this area to the vehicle. So this vehicle will transfer the mirror down to the base camp. So we have to transfer this mirror to a special facility, to the mirror maintenance building, because the mirror needs a recoating. Okay, so this recoating means that we need to remove the aluminum layer with some chemicals, and we need to put a new one, a new aluminum layer. So after this process that takes about 3 or 4 days, we need to put the mirror again in the vehicle. We need to come again to the platform. We need to place the mirror again in the yellow structure. And we have to lift the mirror, and we have to reinstall the mirror in the telescope. So after all this process, the mirror will be ready again for observations, and the mirror will look like a new mirror. So that's why it's so important to do this kind of maintenance. And this maintenance in particular, you need to do that every 2 years.
Okay, thank you, Farid. Um, let's go with another question. Can our viewers, if they happen to have the chance to travel to Chile to visit the observatory in person?
Yes, of course. We have a public visits program during the weekends. So every Saturday, we have two public tours at 10 a.m. and 2 p.m. Each tour takes about 1 hour and a half. This is um, during this time, the people will visit the facilities and the telescopes and everything. This is a daytime tour only. And in order to go to Paranal, you need to do an online booking. So you can visit the ESO website, the official ESO website, um, to book a visit, and the visit is free, but you need to reach the observatory using your own vehicle or service. So in this case, the closest city is Antofagasta. So you need to get a car or vehicle to reach Paraná, but the visit is free, and the visit takes about 1 hour and a half.
Okay, thank you. Um, I think we can continue the tour for now, and I would like to invite our viewers to send us any comments or questions if they have some. We'll have some other opportunity to answer them.
Okay, thank you very much, Hector. We are going to continue then. So, as I told you already, we are going to continue visiting the workplace of the astronomers. So we are going to visit the control building. So the control room of the astronomers is located in the last floor. So we are going to visit this place now. Okay, so we are right now in the control room. So this place is it's like an office space. Okay, so you have basically several workstations, like this one, for example, and each workstation is for one specific telescope. So, for example, this workstation is for the Melipal telescope, the UT3. So we have several computers for different purposes. We have some people working here. So essentially, this workstation belongs only to Melipal. Okay, the workstation in the opposite location is for a different telescope. This is for Jepun or UT4. So only operations with Jepun are from here. So again, you have several terminals, several computers, and some people working here. And if we continue working using this virtual corridor, we will reach the remaining workstations. Here you can see we have the workstation for AN2, UT1. So the same, let's say the same workplace, the different computers on different purposes. And in the opposite direction, we have the last workstation. This workstation belongs to Kuyen. Okay, so we're going to do a close-up here. So essentially, all the telescopes, instruments, and systems explained before and controlled from here. So during the day, engineers, technicians, and scientists are working to prepare the telescopes for the next observation night. So each night we have a telescope operator and an astronomer per telescope. So for example, in this workstation, we have we have this person. This person is a telescope operator, and let's suppose this person is astronomer. Okay, so they are working together here all night, and the telescope operator is essentially in charge of the technical details and the movement of the telescope. So it's like the pilot of the machine. And the ESO astronomer is in charge to direct the scientific observations, and this person will decide the next step. So it's something like the co-pilot. So the observations are performed by experts from ESO for other astronomers from all the planet. Okay, so that's the explanation here in the control room. So we are going to come back to the VLT platform, because right now, now you have a lot more information about the observatory and the people working here. But now I want to invite you to know more about the main scientific milestones made from all ESO observatories. I mean La Silla, Paranal, and Chaknantor, because scientific staff from different countries are using the ESO telescopes to study objects near to our home, the solar system, but also others located in the more distant places in our universe. So now we are going to explore a list of the top 10 discoveries from the ESO sites so far.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it. stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, so this was the top 10. But we have one more thing. We have a bonus track So let's take a look at this important milestone, because a few years ago, a team of astronomers were able to capture the first picture of a black hole. The Event Horizon Telescope, or EST for its acronym, an array of 8 ground-based telescopes distributed on the planet, working as an international collaboration, was able to achieve the first direct evidence of a supermassive black hole. And in this case, the picture will reveal the black hole in the center of Messier 87, a massive galaxy in the close galaxy cluster in the Virgo constellation. This object is located 55 million light-years from Earth, and its mass is about 6,500 million times the mass of our Sun. Okay, so we hope you liked the top 10. This was only a fraction of the discoveries thanks to the ESO telescopes and the scientific staff behind them. So now we can continue, and from the platform again, we are going to do a very special activity thanks to this virtual tour. So we are going to observe the night sky from Paranal. So as you can see, the sky is almost completely dark, with the last traces of light from the twilight. The moon is below the horizon, and the sky is full of stars. So we are going to explore a few popular constellations here. We will take a look at a very popular constellation just about the ANTU telescope, the first one in the picture. So here we have Orion. This is the constellation Orion. See? So in this case, this constellation in the mythology, it represents Hunter. You can recognize Orion with those 3 stars somewhat aligned, okay, representing Orion's belt. And inside of Orion, we can see another interesting object. This is the Great Orion's Nebula. So this is basically a star-forming region that is very bright. It's very easy to see this nebula. Actually, you can see it with your naked eye. Binoculars, even small telescopes, is very, very impressive. Okay, well, now we're going to change the position. We're going to move up there because I want to show you this very bright star. This star is actually the brightest star of the night sky. Its name is Sirius. This star belongs to the Canis Major constellation, and this constellation, Canis Major, represents one of Orion's hunting dogs. Okay, so basically the constellation of Sirius is, let's say, connected in the mythology to Orion. Okay, so we are going to come back to ANTU, and you can see that next to ANTU, right here, we have another object. This is an open star cluster. Its name is the Pleiades. This is an open cluster located in the Taurus constellation. So the majority of those objects are visually close to a specific area, a very populated area with a lot of stars. So actually, when you look at this area here, you can see we have a more concentration of stars here, because this is one of the Milky Way arms. The Milky Way is our galaxy, and our Sun is only one among hundreds of millions of stars. So during the winter, in the southern hemisphere, we can see the center of the Milky Way, and this is another area full of stars between Scorpius and Sagittarius. So you can see all this area from the southern hemisphere. Okay, so now we are going to change the view. We are going to move to another sector in the sky because I want to show you 2 spots. Okay, I want to show you this. So what is this? Well, At this point, we are looking at the Magellanic Clouds. So up there is the large Magellanic Cloud, and down there is the small Magellanic Cloud. They are not actually clouds. They are galaxies. They are irregular galaxies, and both are visible to the naked eye in a clear night like this one from the southern hemisphere. So this name refers to the records from Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So during this time, the people have no idea about what a galaxy is. So that's why in the official records, you can see them like clouds, but not galaxies. Now, next to the Magellanic Clouds, very near, we have another interesting constellation right here. This one is the smallest constellation in the sky. This is the Southern Cross. So you can see it looks like a cross, but in this case is tilted. So this is a very easy constellation to find in the sky, only visible in the southern hemisphere, and a good guide to find the south celestial pole. This is a projection of the Earth's south pole. So during the night, the stars appear to revolve around this point if you take an astrophotography. Now, in the northern hemisphere, the people have Polaris. This is a very bright star next to the north celestial pole. But in the southern hemisphere, we don't have any bright star. So in this case, we need some assistance from the Southern Cross, because one technique to find the South Celestial Pole from here is to extend in our imagination the longer stick of the Southern Cross 4 times and a half. So I am going to do that now. I'm going to extend 1, 2, 3, 4 and a half, and more or less like here we have this the South Celestial Pole. And actually you can find the same point if you try to, let's say, create a triangle using the Magellanic Clouds here. So in one corner you have, well, the South Celestial Pole. And if you look at the horizon, if you try to imagine a straight line to the horizon, you are actually looking at the south cardinal point. So this is an interesting reference in case you want to get some orientation from the stars at night. Okay. Well, so this is the conclusion of the visit to Cerro Paranal. We are going to come back to the main screen at daytime, because we have one last stop, and this stop will be the residence of the observatory. And in order to do that, we have to change the view, because we have to jump to the base camp. The Paranal base camp is located at 2,400 meters above sea level. So as you can see, I am rotating the view because the base camp is located here. Okay, so I want to show you quickly the base camp, because this place is something like a mini city, because we have a lot of facilities here. We have some offices for some people for informatics. We have some rooms for contractors. We have the mirror maintenance building. We have a special workshop facility to fix and create some custom pieces. Well, we have a lot of different things, but I want to show you specifically this place. This place is the residence of Paranal, because in the residence we have, well, this is the place where the ESO staff can stay and rest. The residence is the home of the ESO staff when they are working in the desert. You need to access using this ramp. This place is not exactly underground. It's just taking advantage of the shape of the land. So from this perspective, you can see that we need to use this kind of ramp. We have a dome here. This is the roof. But in the opposite side, it's a normal wall with windows. Okay, so this is not exactly underground. But we are going to visit this place for a few moments because this will be the end of this virtual tour. So as you can see, this is a beautiful place. Here the workers can enjoy a more humid air because well, they have a swimming pool. We have some green areas and well, essentially some rest if you compare with the desert and the intense sunlight from the outside. So the final things here. There we have the restaurant. So all the workers can eat here. Here we have like the lobby, the reception. So this is like a hotel, but the only difference is that this place is only for the staff. Okay? This place has 108 rooms, and most of the time they are all full. Okay, okay. So during this time at the residence, I don't know, Hector, if we have some last questions from our visitors.
Yes, we have a couple of questions. So, starting with this one from Tarak Pandya 5156. He's asking us if this is the place that was used in a James Bond movie.
Yes, one of the James Bond movies, Quantum of Solace, was recorded here. Specifically, this place was like the house for the bad guys, and in the movie, this place explodes actually. But yes, this was the one of the locations for that movie.
Yeah, we have here Gargoyle. He's asking us if you have a live YouTube feed of the observatory sky at night. Do you know something about that?
There is a real-time camera. You can access that from the ESO website, but it's not it's not a camera for the night. Uh, I mean, it's more for daytime. Okay, so for example, if you try to access the ESO website right now, there is a view of the observatory at this time, and you can see the telescopes, and you can actually rotate the view in real time. But this camera is not so sensitive for nighttime. So during the night, you will see just dark. Um, but we have a real-time camera in the and you can visit that from the ESO website. Actually.
Yeah, and just to complement that a bit, it's very normal for observatories to have cameras looking at the sky at night, so the astronomers or the telescope operators can check the sky conditions, so they can see if there are clouds or things like that.
Yes, exactly. So it's more for operational reasons that we have some these kind of cameras.
Yeah, we have here a question from Ignacio Puelma. He's asking us if the center, I guess in the Milky Way center, is only visible in winter.
Yeah, I mean the center of the Milky Way, and this is a distinctive feature of the southern hemisphere. You can see this all the center of the Milky Way and all the galaxy just about you in winter months. I mean, like in okay, let's say even May, but mostly June, July, August. You can see the center of the Milky Way very high in the sky. The rest of the year, well, you have other constellations visible, but yes, during the winter, you can see the center of the Milky Way. This is the best time of the year to observe and to take pictures of the center of the Milky Way in winter months in the southern hemisphere.
Yeah, I think those are all the questions that we have so far.
Okay, So thank you very much for all your questions. So in this case, we are about to finish this presentation. Um, well, I hope you like this virtual experience. Please don't forget to stay alert to the ESO social networks to know when we will have the next tour. And all this visit information and pictures are available on the ESO website. Okay? So we have tours every weekend, Spanish and English, and we alternate Paranal and La Silla. Okay. So from my side, on behalf of PISO, I want to say thank you very much to all of you for your presence. So thank you and goodbye.
Yeah, from my side, I'll also say goodbye, and please share this with everybody that you know that might be interested. And know that you can always go to the ESO website and see a bunch of pictures and video. And I'm just going to answer the last question that just appeared right here. How many days of the year we find clear skies around Paranal? A lot of them, more than I think it's more than 300 clear days per year. And with that, I say my goodbyes and let's see you in a next tour.